So welcome to our next CHI event in our series, Cybersecurity, High Tech, and Artificial Intelligence. Today, our speaker is with us to talk about cybersecurity in the sky, which is a fun topic. Let me introduce my colleague and friend here, Dr. Adrian Lauf. He's an associate professor in the Computer Science and Engineering Department at our University of Louisville J.B. Speed School of Engineering, core faculty member at the Louisville Automation and Robotics Research Institute, fondly known as LARRY, as part of the Autonomous Intelligent Mobile Systems Lab.
That's right.
So lots of acronyms here already.
Yeah.
His research expertise is in cooperative autonomous aerial robotics, which I think we have perhaps an example of at least something similar to this, which has the goal of enabling swarms of autonomous UAVs. So that's another acronym. To accomplish objectives in a cooperative and collaborative manner. This is straight off the website. These robot swarms use multi-domain mesh networking. Decentralized decision making. That's important. And node clustering to improve communication efficiency. Dr. Lauf also has research interests in cyber network security, part of our discussion today, certainly, with research efforts in embedded and IoT, another acronym if you're playing bingo at home. That's a couple right there.
Card for you.
As well as several projects in cybersecurity workforce development where I've had the pleasure of working with Dr. Lauf. I guess I should introduce myself as well. I'm Andrew Wright. I am the chair of a really long department name in the College of Business, Information Systems, Analytics, and Operations. We have lots of different programs that fall under my department. The relevant one is the undergrad in Computer Information Systems with a track in Cybersecurity, which is one of our two centers of academic excellence in cyber defense. So, welcome everyone who's here with us at Hive and everyone at home. It is my pleasure to talk about the subject.
And I should just interject real quick.
It
is also a privilege of mine to be associated with Hive and to be a core collaborator in that since its inception.
Yes, absolutely.
We just need a great website.
A great space to be in. One of my students actually was the founding spirit here.
That's
kindred with
this.
We see his design decorations everywhere here.
Mm-hmm.
So let's start with a question kind of about your professional and academic journey. How did you get here? How did you get to be a professor here at the University of Louisville?
Well, if only I knew. No. So I guess from a very early age, nerddom was evident, and my parents were both academics.
Right.
So I was very familiar with the environment. I roamed the halls of Wright State University since I could walk, and I knew all the equipment. They would have test tube shakers with the on switch, like permanently in the on position.
Right.
I would put my hand on top. It would shake my hand to the point where all my nerves would go numb. It was, I would sit there for hours playing with a vacuum, suction systems. I just loved playing with equipment. And when I was about 4 years old or so, I had a cousin who stayed with us doing his master's in mechanical engineering.
Okay.
And he taught me how to fix broken gear teeth on my toys.
Oh.
And the answer is four. The answer is tape. If you put tape
and a rubber band solution.
Right. And it expands the broken gear teeth just slightly enough that you can have a few more hours of fun with the toy. Destroyed. But that, to me, the fact that I could affect something in the real world and not just draw on a piece of paper was mind blowing, and that opened up engineering, I think, for me. And I think by the time I was 6 or 7, I was batch script programming. I did all the usual mistakes of setting up a recursive loop on my dad's computer where it never finished booting. I didn't know you could just Control-C out of it, so I formatted his entire computer to fix it.
Oh, I love it.
And then, and really the interest in computing and electronics started because my mother bought an electronic projects playground for a friend of mine, and I was so insanely jealous. I said, I have to have one of these. she finally got me, and by literally the end of the week, I had done every single project in the book, and I was just craving for more. So yeah, that kind of started that journey, and I think in high school I already knew very much what I wanted to do. I loved the academic environment, and then so I went to Vanderbilt. I studied music performance, cello performance, and computer engineering.
Right. I was going to mention that you're a gifted musician as well.
Yeah, and that's actually how I met my wife over there. But yeah, it's a wild thing. I don't know if I'd even recommend it to myself to do it after many years of introspection. But it was a lot of effort, but I enjoyed it. I really gravitated towards embedded systems. I took a microcontrollers class. I loved every moment of it. And then I love networking as well. So all these things kind of started to coalesce. And cybersecurity came into the picture when I started my master's/PhD.
Okay.
I started off as just a TA. And I was a teaching assistant for actually a former faculty member here now, Andy Dozier, who was over at ECE. Very influential guy, actually. He had a long career in industry before he came back to Vanderbilt and taught project management, and then he came back here. This is his hometown.
Gotcha.
Taught here for a little bit, and then went back to industry before he retired. And I was TAing for that class. I was also the entire time working in Vanderbilt's information technology services. So I had exposure to cybersecurity that I didn't know that I had, right? And keep in mind, cybersecurity at this time was a buzzword. Nobody did anything about it. We're talking about web pages that would show like technical stack dumps to users when something didn't work, right? Which is a big no-no today. Yeah. And then, yeah, so I was a TA in my first part of grad school, first semester, and then I had a professor call me. He was part of ISIS, that is the Institute for Software Integrated Systems.
That one.
The good one. Before the name was sullied. And he said, "Hey, Adrian, I had you for an FP8 course. I enjoyed working with you. Would you want to be a research assistant for me?" In a cybersecurity program. It was called the Team for Research in Ubiquitous Secure Technology. Yes, it's an acronym in search of a name. It's TRUST. It was an 8-school project. I think it was funded at $20 million at the time, which was quite big. And so I said, "Can you give me 24 hours to think about it?" My answer should have been immediately yes. But stupidly, I said, "Let me think about it," because I said, cybersecurity. I don't know the first thing about cybersecurity. Truth is, you already do. Cybersecurity is people, right? And then how do people use technology? People focus so much on the technological side.
Right.
Not enough on people.
That's why we have a program in the business school.
That's what we're going to talk a little bit about on this. But so thankfully, I came to my senses, and the next day I said, "Yes, absolutely, 1,000 times yes, I'll do this." And that started my career in cybersecurity, but I was still focused very much on embedded hardware. And then I was going to do a postdoc at UC Berkeley, and this was in 2010. Everything was crashing. I already had basically a spot, but right when I was about to graduate, or right after I had defended, something like that, I got a message that said the program funding has been cut. This is not happening. So I quickly sent out applications. It was way too late at this point. And then I just for fun, I reached out to for necessity, I reached out to my parents' university. There was a chairman there in the mechanical engineering department. And I said, "Hey, I do a lot of work on drones. That's what I had spent a lot of my PhD on, networking, task allocation. But I just like to play with airplanes." So, yeah. And so they took me on for a year as basically a research assistant professor, postdoc kind of. Did that for a year. Unknowingly, I had missed an email from Dr. Almagravi to come visit U of L right as I was graduating Vanderbilt. But fortunately, I don't know if it went spam or what, but fortunately, I got it again. And came down and visited him.
Nothing is not persistent.
Yeah, no, he's wonderful.
Our illustrious leader, who unfortunately cannot be here today, he's out of the country. Big shock, I'm sure, to no one in this room.
Well, he is. I think he's wired in. So
yeah, might be. Yeah, we'll be checking the chat messages here.
So
He just gave you the
Big thumbs up. Okay.
Dr. Elmagrabi is the reason for so many good things at this university and for why I'm here. So
he was, on my dissertation committee.
yeah. I mean, I think literally every one of us is
Right.
connected very closely to him. So yeah. So that's my journey of how I got into it. Once I started here, I continued to work kind of on the networking side of embedded systems, specifically in drones, and I have plenty to talk about on this. But
Yes.
I would say that in 2013, I had students and I was teaching embedded classes, right? I was teaching microcomputer design, which is CSC 525. I give you a bare CPU. What kind of friends does it need to have a good life, right? And then I taught the microcontrollers class. I taught a couple other stuff in between. And then in 2013, I had some students come to me, specifically Jimmy Murphy, who is also a very good friend of all of ours, said, "Hey, Lauf, you need to teach a NetSec class." It's like, oh, God, I don't know the first thing about network security. And again, this is a fallacy. All of you guys, everyone here, has some core understanding of principles of cybersecurity. If you understand people, you understand the core principles of cybersecurity. Technology is a component of it. We'll talk about that as well. But, and so that's kind of started it. And, Dr. Elmagrabi also put me in with the whole recertifying our NSA CAE and those kinds of things. So a lot of cybersecurity kind of ramped up, and we've been involved in that ever since.
And
So
I think we probably started working 2017.
yeah, on NSA grants. Yeah. So you and I have a long history of that now. Yeah, time
Fun
flies.
stuff. Well, thank you for that.
Sorry, super long.
No.
You know how professors are. We're just
Right.
terrible.
I've got a whole bunch of questions.
Okay.
We'll get through two of them, but
We'll get through them.
it's good to hear that background and the music part. I'm always fascinated because I certainly believe, even though I'm a terrible musician, that there is a connection between
100%.
music and STEM and
Yep. It's all differential. No, I don't.
creative juices
Yeah,
that get
100%.
flowing there.
The great part is I could have too much of engineering. So like I had way too many engineering classes, and I was like, hey, let me go to School of Music and do something completely different.
Yeah.
And then I had enough of practicing, and I'd go back and do homework. And
Right.
it was
All parts of your brain
Yep.
being activated
That was great.
in a week. That's awesome.
No social life, but I had,
Very visible.
And your doctorate was from Vanderbilt, right?
that's right. Yeah.
So our discussion today was couched as, cybersecurity in the sky.
Mhm.
So what are we talking about being in the sky? I see, drones, UAVs, unmanned aerial vehicles, all acronyms. We have personal use devices. I remember we were at IBM, TJ Watts Research Lab. You pull the drone out.
Yeah, I wanted to
And
get
they threatened that it was going to get shot down because this was, forbidden at the high security site.
That's right.
Commercial applications of these things now, military devices, obviously. All acronyms all the time. So what are we talking about?
Well, I mean, and you could really say that the military side has kind of exploded. Pun intended. But
Literally.
it has. So the UAV is interesting, the unmanned aerial vehicle, right? And its counterpart, the unmanned aerial system, which is the ground control stations, the aircraft or multiple aircraft, communication linkages, networks, everything, right? So UAV, UAS is fascinating because every kid dreams to fly, and as a sensor platform, there are a lot of unrealized potentials. But I also see it heavily used as a solution in search of a problem, right? Because I think when you can trace back, model aircraft and small scale flying aircraft have definite transition points, right? So 40s, 50s, 60s saw like control line aircraft that people flew for fun. And then, small engines became more capable and radio control systems started taking off in the 60s and 70s. So you started seeing remote control aircraft, but they only had fixed channels. So you can only fly like 6 airplanes nearby, or you could watch some spectacular crashes, right? And then spread spectrum hit in the late 90s, early 2000s. And oh my God, we can have thousands of these things flying because of digital radios and spread spectrum.
Right. The same thing that let us have all those wireless phones in our
Correct.
homes that didn't interfere with
CDMA, CDMA, OFDMA, all those guys.
Yeah.
And then but they were still fixed wing kind of things, right? And they were hobby aircraft. There was no real purpose yes, you could argue that the Reaper program was taking off again. You're going to see a lot of puns today. Sorry. And that led to militarization and drones. By the way, the term drone goes way back to the 1930s and 40s when these were used for target practice. These were gasoline powered things. They had no control system. Some of them had radios. And they were used for target practice, and that was kind of it.
Step up from skeet shooting, I guess.
Yeah, pretty much. That was literally the purpose of these aircraft. They couldn't really figure out what else to do with them. They didn't have cameras and wireless technology, so for sensing platforms, they were kind of useless. But if you then look right around the late 2000s to early 20, so like right around 2008, 2010. The advent of the MEMS, the micro electromechanical switch accelerometer, which existed prior to this but was expensive,
right?
And the ability to get cheap microcontrollers that had extensive community support, like Arduinos, the 18 mega 328PB, which sits at the heart of most of the original Arduino Unos. It's a well-known architecture, but people really started to develop library support and all sorts of easy to flash stuff, because microcontrollers before then, you had to have an SDK for it. You had to have a debugger for it, a hardware piece of equipment that you pay $1,000 for just to program the darn thing. Our early Motorola 68HC11s, which we taught in 412, a whole desk full just for one little microcontroller that big, right? Emulator boards, wildly complicated stuff for a relatively simple thing. And these things had 256 bytes of RAM, by the way. You can't even think in 256 bytes. Right. And I cut my teeth on those. It was rough. But modern microcontrollers with lots of onboard memory, a couple kilobytes, easy to program, and MEMS gyros changed everything. My first drone that I built in undergrad, which had an autopilot on board, I couldn't afford the MEMS gyros because they just weren't a thing. And my first drone literally had thermopiles, which would measure temperature. And the sky is always colder than the ground, even in dead of winter. And that's how it knew how to control itself. Yeah, right. It was always saying, which way's up? And it would have 4 thermopiles looking out this way. And the thing would fly a little bit like this, just which way's up, which way's up. And then it would have some facing up and down, so it knew if it was somehow flying upside down, maybe, which would be really bad. And then it would just kind of oscillate a little bit just to keep the skyline in view, the horizon. And that's how these things flew. It was literally cheaper to use like a little thermopile or microbolometer sort of than to have a MEMS gyro. And once that changed, everything got cheap. Electronic speed controllers with high-end MOSFETs came out that were trivial to purchase. And the first things of this category were like $2,000 or $3,000, but that's still so much cheaper than 10 or 20 that it used to be. And now, this is straight from my Larry lab. I wonder if any students are going to find it missing here in the next few minutes. But I did steal this. This is, we built these. This is laser cut and 3D printed in my basement. These are cheap airframes that we use. And yes, it's made of wood because it's very durable. These things take multiple 16-foot falls and they're just fine. These are made possible, and this is like $300 worth of tech, and this has autopilots on board and a Raspberry Pi and all sorts of really advanced stuff. That's possible because of these mass market components that were just not possible before. It's wild how low the cost of the entry is now. And so that has created a totally different market where you have people think drone and then application. It may not be a good application. I've seen people using drones for pressure washing buildings. Well, is it good? Maybe. Is it going to take you 10 hours and 20 battery changes? Maybe.
The physics of that
the physics are always what gets in the way. So you end up with lithium-ion batteries, which, I have them in the car. You have them in your car.
Right. We share a fascination with electric vehicles.
They're great. But they don't have the energy density of combustion, of gasoline. Although, of course, a combustion engine wastes 80% of its energy as heat, which is unusable. So, I had gas-powered planes as well. They use nitromethane, and they could run for a while. They could also flame out in midair, which happened a lot. And then you'd have to dead stick land this thing. Well, you can't use that for these because these motors, these are brushless outrunner motors, they get controlled at about 60 to 120 times a second, changing their speed. You can only do that with electric motors, but the battery still remains the critical weak point, right? They're heavy, their energy density, as high as lithium ion is, it's really good, but it's still not fantastic. So we're talking about 5-minute flight times, 10-minute flight times on some really high-end commercial stuff where you pay 20 grand for the aircraft, maybe an hour, right? And so that's your limiting factor. And I think that limits a lot of what the potential is.
And if they're carrying my Amazon,
Right.
delivery to my home, yeah, I mean, lots of expectations about, these drones, and, the critical question for me is when am I,
When you're getting your package.
Yeah, right. And my Starbucks delivery in the morning.
Well,
need some.
number one, the battery, and it is the best solution, period. There's no other solution for these aircraft than a lithium ion battery, or maybe, some sort of solid state battery if they come out.
Soon, yeah.
Coming soon, TM for the last 20 years.
That's right.
They may. I'm not saying they can't, but durability has been an issue.
Yeah.
The weight of the battery, the more weight you have, the more you have to counteract that with motors, which means the more power you consume. So therefore you need a bigger battery, which adds more weight, so you need more power.
Right.
Everything's got a point
there.
So the weight is an issue, right? And there are trade-offs, and if you've been a student of mine, you've heard me say engineering is about trade-offs. I say countlessly. This has a great trade-off, which is maneuverability, but of course you're trading off stability. And in order to get stability, you need a lot of power consumption, because the rotating wings, which are these propellers, are the source of lift, and also the source of thrust, and also the source of, differential inputs. And that's extremely power hungry. A fixed wing using the same battery would last 5-10 times as long. I'm exaggerating, but a lot longer in the sky than this will. But you can think about package delivery and things like that. And then, of course, the power is one thing, and that's solvable. There's some really big airframes that, the folks at Project Wing are doing from Google. They've got a really cool VTOL architecture with a fly-through package pickup mechanism, and they can hold a couple pounds. We've designed an automatic emergency defibrillator aircraft. It's sitting in my office over at Larry. Yeah. It holds 12 pounds. It's heavy. It's really heavy. It takes like 80 amps of current to run the thing, and it's deafening. But it does it for 10, 15 minutes. And so you can come up with excellent platforms. Amazon has their own. But then you have the whole regulatory framework, right? If I say BV loss, which is beyond visual line of sight, it's a no-no. You have to get very special exemptions in order to do any of that, and for very good reasons. Something falling from 400 feet will kill you. I mean, there's no bones about it, right? There's no ambiguity there. I mean, if it doesn't kill you, it's a miracle, right? I mean, 1/2 mv squared, all that kind of stuff.
Yeah.
And it's a lot of mass. So, and as you may know, if one of these stops spinning, it's catastrophic. This thing is not recovering itself. A fixed wing, you can dead stick land sometimes. These don't have an alternative. So that's why the regulatory landscape is so slow to adapt. People want to be really, really careful about not hurting people. It's only going to take one delivery drone hurting somebody, and the entire thing gets shut down.
I have a question about
Yeah.
that. You've already checked that off my list here.
All right, great. We're able to be productive.
Right. Let's delve into the cyber side of things a bit.
Yeah.
The risk factors for these things, and some people in our audience certainly have an understanding of what we think of as traditional cybersecurity stuff. So what is really different about this than what we think of as the risk profile for our normal connected stuff?
So we typically tend to think of cybersecurity as, a scammer is asking you to invest in a bunk crypto scheme, or someone has put ransomware on your computer. Well, you put the ransomware on your computer because you weren't paying attention, but
Right.
and it's very easy to have happen. But someone has tricked you into doing something on a computer, right? That's typically what we see. I actually got my first bug bounty yesterday. I was super pleased.
Congratulations.
Thank you. But nonetheless, we tend to think of cybersecurity as something isolated to a computer or a phone, and phones are pretty locked down. I mean, manufacturers are very keen on making sure that not too much can go wrong, although they are still great vectors to trick you into other schemes because phones are relatively open-ended devices. But we don't think of cybersecurity in the area of unmanned aerial systems. And it's almost 10 years ago, I co-authored a paper where we tested the cybersecurity resiliency of some of these platforms. And at least back at the time, it was horrific. We had one attack where we were able to a lot of drones were using Wi-Fi as their radio link technology. Some of them still use, traditional, modulated digital spread spectrum communications, which are even completely unsecured. They're bound, but that doesn't really mean much. But we were able to de-authenticate the remote part, the controller, re-authenticate the drone to us.
Yeah.
Because it had no security. We claimed access point, basically.
Yeah.
And then we were able to basically remove the drone from the operator. There were other attacks we were able to demonstrate, such as the ability to overload the mobile processor using radio link techniques and essentially spamming the thing.
Yeah.
It was already low enough on power as it was. And that would eventually cause the control loop to crash, and therefore the aircraft to crash. So there's a lot of things that you would think about. Now, we don't see these everywhere, right? These drones are not flying overhead, and I mean, it'd kind of be a little bit annoying if they were, and terrifying. But think about it. Aircraft, when they take off with a UPS jet, that's all flying on autopilot. I mean, realistically, a pilot's hitting a button, even for takeoff and landing. In fact, it's to the point where, and this is information from like 10 years ago, pilots are required to do X number of takeoffs and landings manually so that they can remember how to do it.
But they don't do it very often.
They don't do it often. When you're flying in an airliner, it's a computer flying you, right? Takeoff, navigation, landing. It's all computer controlled because computers can respond much faster to most weather conditions. There is still something to be said for experience and a lot of avoided crashes from just like muscle memory from a pilot. So yeah, they have to take over from time to time just so they can remember how to do it, right? But cybersecurity affects airliners, and there have been alleged proof of concepts that one aircraft was caught. They dipped an aircraft because of overloading, inserting commands on a CAN bus, whether or not that's actually true.
Our vehicles as well. I mean, there's
absolutely
some of these same attacks.
So yeah, I'm working on an older car, trying to take over its brain a little bit so that I can upgrade some sensor technology on there. And even back then, this is a 10-year-old car that I'm working with, it has encrypted communications for good reason, because you don't want to just be able to plug in something over the OBD port and now the car is taking commands from something that it shouldn't. Everybody always quips about the cut brake lines, but you can do so much more with technology.
Right.
If you have accelerator control, steering control, brake control, or lack thereof. Yeah.
One of my students recently, this is his area, is
car hacking. Yeah.
Yeah.
There were some cool demos at a conference. I just went to one of the CAE conferences. They had a car hacking demo there as well.
So which components of these drone systems, the communication link, the onboard sensors, the ground control stations, which are the most susceptible to?
Yeah, all of the above. I would have to say, because, you've probably heard of, this is also 5-10 years ago, where vehicles with level 2 ADAS, adaptive cruise control, that kind of stuff, people were able to fool them by placing infrared reflective dots on speed limit signs where you can't see it necessarily, but under certain conditions the car can. It would slam on the brakes, or do something that would cause the camera systems to perceive something. And the same goes for sensors on here. We are using these to do essentially structural assessment after a natural disaster. Think of using LiDAR, which is light detection and ranging. We're using really cheap components. Yes, you can spend 50 to 100 grand on a really nice aircraft and LiDAR unit, right? But we're using $50 parts to try to do the same thing, to potentiate an emergency management team or a police department, whatever it might be, to buy a couple of these for next to nothing and have a little swarm that can go assess. Think about first responders, right? They go where they're needed first. But if you don't know where they're needed, how do you allocate that? Or how do you know where the roads are washed out? Or how do you know how critical a building is? Well, traditionally, you send a helicopter up, right? Yeah. Send a helicopter up in the air, but that's one person, one camera person, limited fuel, limited resources. Can we automate that? And that's our goal. Well, there's sensor platforms on here. One potential vector is there's a magnetometer on here, which tells it the absolute orientation of the aircraft relative to the magnetic north of the Earth. If I mess with that, this aircraft doesn't know which way it's flying, and that's a problem, right? And it's not that hard to mess with it. I mean, potentially. The radio links. This communicates over Wi-Fi, encrypted Wi-Fi, but as part of my network security class, we performed deauthentication attacks. And if I had a really stupid Wi-Fi password and it's dictionaryable, you can recover that. Right. So
unsafe defaults that are
unsafe defaults, yeah. and there are a lot of unsafe defaults. Or you'll have seen probably in the news drone cannons, which use concentrated RF bursts essentially to overload the electronics on here, cause them to reboot. Well, if the thing running your control algorithm is rebooting, you're not controlling anything. Yeah. And you know how well these things work without props. They are paperweights. So they literally fall out of the sky. And so, drones are not ubiquitous yet. I think we'll see critical applications first, like organ donor transport. So, they're already being used for that. They're already being used in some delivery cases. Mm-hmm. I don't think the delivery space is quite ripe for it, personally, because it's still efficient. Let's say you have an electric delivery van, which has almost no power consumption on the road to move from space to space. You hire somebody, whatever their going rate is, they get the packages out. It still might end up being cheaper than having to figure out how to send out a bunch of these.
And while we were in New York at a cybersecurity conference with the FBI, we saw a lot of those alternate
EDVs. Yeah, they're awesome. Yeah,
which was cool. Drones, at one of these application areas, using swarms of drones for finding missing children and things like that. There's lots of those applications. How does the swarm or the kind of the collaborative work with the drones complicate the cybersecurity defenses?
Right. Okay.
So that having these grouped together.
Right. Excellent question. So the reason we're using swarms in the first place, we have to address that first. The reason we're using them in the first place is because we're just trying to force multiply, right? But not just force multiply. We need resiliency. So if there are issues with these and one of them drops off for whatever reason, battery quits, avionics quit, motor dies, prop got bent, bird strike, whatever. Birds don't like these, by the way. They'll go after them. If you have that kind of an event, you need resiliency of the network. So that's kind of baked into what we're doing, is the ability to dynamically reallocate the sensing task if you have a loss of one or more aircraft. And so we're very interested in decentralized sensing, right? We don't want a single link to cause everything to fail. So that's why we swarm. And if you've ever worked on a project with someone, things go faster when you have more than one person working with them. So speed, reliability, and kind of access bandwidth, if you will, is potentiated with swarms. Well, that then brings up the question, what if I have a malicious actor who's interested in breaking the radio links? So we use, for the swarms, we use a we use just ad hoc Wi-Fi networks, which are well proven. They are encrypted, so you can't just sniff and get on. But they are also using a routing protocol that allows the aircraft to move in and out of range of each other, and they go from hop to hop accordingly. And the networking system we used is called Batman. It's the better approach to mobile ad hoc networking.
Love it.
It's a protocol about 15 years old. It's very effective. It doesn't require any custom radios because all of these have Raspberry Pis on board, right? We have a split brain approach for these. We've got our autopilot unit that just tells this is kind of the brain stem. It just lets the thing fly. And we have a Raspberry Pi on board, and that's what's doing the high-level coordination, the networking, all that kind of stuff. And they're tied together. All the Raspberry Pis have Wi-Fi radios built in today, so it's very easy to get them to link up in an ad hoc network. There's almost nothing you have to do. There's no equipment you got to plug in. It just kind of works. Yes, there are other technologies like LoRa, which is a long-range radio network, but that's roughly 50 kilobits per second. It's not going to cut it. So we rely on 802.11. Works really well. We get enough bandwidth to move pictures and control signals. That's the idea. Yeah. So to your question, how does cybersecurity apply there? It applies in the same way that any networked Internet of Things device, IoT device, would in that context.
Cool. We'd be remiss to be in this space and not talk about AI.
Absolutely.
So what are the emerging threats from AI-enabled adversaries?
All right. So I have I have a couple of papers on this with a PhD student of mine who graduated a few years back. And he was actually using AI on the detection side of things. And specifically, I mean, as you may realize, I mean, just looking at various antennas poking out of this thing, there's one, and there's two in there. This thing has a pretty big radio frequency footprint. Yeah. And so we don't just have to think of security in terms of the aircraft itself, but also protecting ourselves from intrusions from aircraft that we're not interested in having around. If you've seen the latest stuff from DJI, you might be aware that the propeller tip designs are created so that the turbulent flow is so minimized that it's nearly impossible that they shed these trailing edge vortices in such a way that is so minimal that you can barely hear the darn things. Like, you have to have a really tuned ear to pick out some of the. I have a neighbor of mine who was learning to fly a DJI Mini 3, I think. I saw it. I can hear it.
Couldn't hear it.
I have pretty good hearing, for the most part, and only under specific circumstances can you hear it. So these things are getting a lot quieter, and it's easier to intrude, whether intentionally or not, upon people. So this paper that we worked on, he went to North Carolina to a testing facility there. He got a really nice 6 gigahertz oscilloscope to work with there, and collected tons of raw data on signal sources, Bluetooth, Wi-Fi, both from smartwatches and any other technologies nearby, screened those out, and then just got the raw data from the drones. So they did this out in a really wide open field away from signal noise, or from random RF noise. And we built a data set, and we built a neural network that was able to classify, okay, this is a drone coming in, or no, that's just someone's Apple Watch or whatever it might be, right? Because you want to know that. And there are various ways that you can see a drone coming. Obviously, you can look for them. There are artificial neural networks that are designed to identify them based on the looks, but you only get so much range with a camera. There are auditory ways you can tell, of course, although that's constantly evolving. So we focus on radio frequency. Can we identify an incoming friendly or foe? And not only were we able to, with high reliability, identify the presence of one of these aircraft, we were able to determine what it was doing. So was it hovering? Was it getting a fly forward command? Was it streaming video? Those kinds of things, all without decoding the signal itself. Because it's encrypted, we didn't want to bother with that. But we were able to, from the RF space, essentially we're using SDR, software-defined radio, figure out what was happening on that drone, which is super cool. Yeah.
Impressive. In the interest of time,
I don't know, how are we?
We're good. I mean, we got about 20 minutes left, but I will have a lot of questions.
Let's go.
I'm going to hit a variety of them. One of our guests in the audience today, the illustrious Michael Basavio, would we be remiss if we didn't ask about the privacy side of these things? Where does this intersection between the privacy interests of people and the way the drones are being used in surveillance and other ways?
Excellent question. And I mean, I've actually seen, I don't really do social media, but I get like emails from like next door and says, there was a drone peeking my window the other day or something like that. So the low cost, ubiquity, and video streaming capabilities of these aircraft for the consumer side make it very tempting to make them do things you're not really supposed to do with them. And so if you look at what FAA has done with its Section 107 rules, which state what you can and should not do if you're recreationally flying, have weight restrictions, and the weight restrictions are very interesting. The weight restrictions come down to, well, how much could someone get hurt with one of these things if it falls? 2, is it heavy enough for you to have loaded it with explosives? And 3, does this give you like supernatural like battery life and runtime and transmission length? So the weight is a really easy way to reduce essentially the capability set of one of these things, right? DJI, when I picked up one of their latest, like literally lifted one of their latest minis. They're made with a plastic that is like mostly air.
Yeah.
It's amazing how light they are to skirt under the 250 gram exemption rule, which is completely unregulated. 250 grams, and below that's below 55 pounds. I don't know why they have grams in one and pounds in the other. Go figure. I would say ask someone at the FAA, but I don't think they'll answer their phones today.
Right.
So they have these interesting weight classes, right? And that dictates a lot of what these passively dictates what they can do.
But right, the weight.
Right. So the rules in Part 107 are there to try to protect people passively. There are efforts in place to have essentially super capable radars throughout the entire country that can essentially determine the number of these things that are flying. I don't know where that went, but I know it was an attempt to at least figure out, okay, how much of the airspace is being used. By the way, does anybody know how high up you have to be in regulated airspace?
500 feet.
1 millimeter.
Oh.
So if you jump, you're an aircraft.
Oh.
So airspace starts 1 millimeter over ground. At least that's what I remember studying a while back. Maybe that's changed. But yeah, an aircraft is anything that literally is not attached to the ground. If you go over speed up too fast, you're now.
Right. Several times.
And so, yeah, that's all regular. Most of it's Class G, which is, wide open, you can hobby fly and that kind of stuff. But, commercial flights still heavily restricted. You have to go through at least some Section 107 exemptions. And then if you want to be on visual line of sight, that's really hard to get. Or you need a certificate of authorization if you're a university and you want to fly like a prototype aircraft. That's really hard to get. You have to tell them exactly what day you're going to fly, what time window you're going to fly. They have to direct aircraft out of the area. It's wild. And that was actually an impediment to research institutions that were using these to study weather phenomena like tornadoes. Like I'm going to give you a month in advance notice when that tornado is going to hit and where it's going to be.
That's the other department next door that's creating the weather control system.
So, right. So that had to be one of those.
That was our cat, though.
That had to be one of those beg for forgiveness instead of asking for permission kind of things. And there's a project, by the way. If you guys get a chance to check this out, go on YouTube and look up the Otis project, OTUS. They fly these things into real tornadoes. It's wild to watch these things. The most interesting ones are not the super powerful EF3, EF4s. It's the EF1s, because they'll fly right in. You get a perfectly clear view of little micro vortices spinning up, and you just spin around with the tornado. It's something else. Put it on a big screen. Enjoy.
We lost our fire behind us.
Oh, there it is. There it is.
Goodness.
Never lost my fire. What are you talking
Can't be a fire hydrant. No need. I'll speak for myself.
The tornado blew it out.
Well, you mentioned the FAA, and so what you've been speaking about are not so much their efforts in terms of aviation authorities. What about their efforts on the cybersecurity front? In particular, are there things that they're specifying as part of this to help the cybersecurity aspect?
Not yet. I would suspect, and I fully acknowledge that I'm not up to speed on what those efforts may be. Maybe we should start them.
Yeah.
But I think there is so much lethargy in even validating what permissible flight is that I'm sure that there's a number of individuals working in the research space for figuring that out, but policy is such a slow-moving thing. I mean, look at autonomous vehicle policies. There's only so many states, like 3 or 4 or 5, where you can even do that because there's so many considerations. People are uncomfortable or they're comfortable. They want it. They don't want it. Lawmakers don't want to probably have an incident on their hands because they signed off on something and someone was killed or or injured or whatever it might be. And so it's a very slow moving thing. And I think cybersecurity as a broad strokes thing already exists. It has a very heavily government driven component or research driven component in IoT networks, stuff like that would apply. But I haven't seen any effort specifically on, hey, you need to keep a good leash on your aircraft when you take it out for a walk.
Well, are there lessons to be learned from the traditional aviation side of things with regard to cybersecurity? I joke. They keep telling me I have to put my phone in airplane mode, or the plane might come down. Are there things there that translate well into these smaller devices?
So there's a parallel to that. There are a number of aircraft companies that are developing electric short haul, and I've forgotten the acronym for this, so my apologies, but they have a particular name, and we were at a meeting with UPS and they showed us these. They're electric. They charge at about a megawatt or so at the thing. They're for package delivery and they're autonomous. And autonomous flight has been a thing for a long time. It's not like cars where we have to watch out for kids running across the street or stuff like that, right? Kids crossing the street in the air, that's a whole other problem.
That's a future.
So autonomous short haul package delivery with electric aircraft is a thing. And that is very tightly regulated, of course. All the same regulations and more as a traditional airliner would, because it's beyond visual line of sight. There's nobody on board. And these things are in trial right now. And they would solve several big problems, which is the in-between hub hops that they might have for local areas. Like if you needed to get from here to Lexington with packages, you don't want an aircraft that's going to spend, half an hour reaching altitude and then another half hour going down. The flight's not that long. You might as well just put it on a truck. But for these small regional hub hops, these are very interesting alternatives. They don't have nearly the same carbon emissions as, of course, an aircraft, a traditional combustion aircraft, jet engine would. So they're very appealing. And there's a lot of work being done to validate them and to be able to integrate them with the airspace. And the integration with the airspace is the critical issue, because how do you get other pilots to know, hey, one of these is coming? So some of you may know, if you're following general aviation at all, there's a service called ADSB, which is a broadcast system. And it's a transponder system that you broadcast your aircraft's position. I forget the acronym for it. It's a cool acronym. And you broadcast your position in your aircraft identifier. And all the aircraft are doing this. In fact, DJI aircraft can receive this and tell you an aircraft's nearby because they pick up the beacon. And so, there's all sorts of integration with airspace that these short hop package delivery aircraft are integrating. And I think that's going to be the closest analog to something like this, because they have to solve the beyond visual line of sight problem. They have to solve certification issues. They have to solve And their electric aircraft like this, just totally different. They're traditional. So that's the closest analog in the aviation industry, I think. And if you look at a traditional aircraft, some of you may know this, but every airliner you go, there is no physical linkage between the control sticks and computers in the cab, the cockpit, and the rest of the aircraft, right? There's no cables. If you look at a Boeing 727, which is an aircraft from the 1960s, there are physical cables. Everything else, modern aircraft, they all have computer actuated hydraulics. They're all on a CAN bus, which is a known quantity. We know how to talk CAN. They're highly set up in a way that makes it very difficult to insert spurious commands. But nonetheless, they use a common data bus. And trust me, you really want this because cables break. You're much more likely to have a cable break. And in fact, they have 2 or 3 cables per control surface on the old school airplanes because of cable break. They rust. And when it gets stormy outside or icy, the pilots can't move the control surface.
And when those MFing snakes are
the snakes on the plane, it takes a tremendous amount of effort to move an airliner's control surfaces by hand. So you really want the hydraulics. They're much more reliable. But all those, how do you provide reliable communications between all those parts? Those are also lessons learned from the aviation airline sector, I would say.
So we're building on.
Yeah.
That's good. Well, let's switch to what's keeping you up at night with this stuff.
Oh boy,
I know you had mentioned in an earlier conversation about airborne bombs.
Yeah,
and and is AI something that's keeping you up at night in this space, or just in general? Perhaps we should all
right.
If you're our friend Roman.
Well. Okay, so AI has a multi-partite role in a lot of this, right? We can use AI to ascertain data that we're seeing from cameras to make assessments about conditions of things on the ground. We can use it to understand structural information. So we can use it for sensing, right? It's great for sensing. We can use it to, I have some work with another PhD student of mine. We were assessing link quality dynamically. In other words, how do you know if the link is about to die? AI is used for that. It can be. It's not actively used in most circumstances, but it can be. Actually, in my Unify switches, AI is used to detect port flapping, and it'll give you a score. So it can be used for a lot of maintenance or functionality assessment of something. So that's a good thing, right? We don't want our communications links to quit, and a pilot, whether for hobby or anything else, would ideally know well ahead of time before he's out of range. Okay, before they are out of range is critically important, because then what happens when you lose the radio link? Well, if your aircraft is smart, it returns back home on its own, and if it's not smart, it's going to flip. And so. That's another excellent use for AI on the positive side of things. More so on what keeps me up at night is, well, I mean, I guess this is neutral, but large scale training using information that we might not be willing to give up. Should people be training on my backyard with my kids running around or not?
Right.
I was on one of my AWS boxes yesterday, and it was slowing to a crawl. And Apache, the web server, was getting absolutely hammered to oblivion. So what the hell is going on? Am I being DDoSed? Am I being attacked? Looked at the network interfaces, looked at the access. It was Anthropic. It was just combing every possible nanometer of web real estate on this box, and it was borderline malicious how fast it was trying to extract data from this poor old web server that
AI much
barely handled the traffic. Right. And so I think we have to be cognizant of how we're allowing, or how we're as a society making acceptable training. If you're training around a mountain, is natural landscapes, go for it. But what about people? What are we asking for forgiveness instead of for permission now? in terms of training visual models and stuff like that. That's one thing I would say.
Yeah. I'd rather not have things falling out of the sky and landing on my head, although I've read an interesting statistic about Starlink. And how many of those things are just
for a day
falling every day.
Yeah.
Right.
So the burn rate is quite high. Yeah. And then you have other things, communications. So how many of you guys are familiar with like the Hack RF1 or RTL SDR or something like that? The software-defined radios? Okay, so these are phenomenal, and I've been playing with one all week, just sniffing around various frequency spaces, just seeing what's going on. It's wild stuff. It's super cool. You can actually build an amazing profile of someone's smart home usage from one of these. You can tell which devices are battery operated and which ones aren't, because the ones that are battery operated, they get absolutely slammed in the RF space to wake them up.
Yeah.
Right. So signals gathering and signal intelligence. It is, WPA2 is pretty okay. WPA3 is pretty good for Wi-Fi protection. But what if you have, and I actually have a student who's working right now on essentially creating a Google Maps of crappy Wi-Fi passwords. And we've built a flying network attacker basically. Yeah. And it uses deauthentication attacks to essentially knock people off their networks and then capture the password hash and then run it through an attack to see if it's dictionaryable.
So it used to be drive-by, now it's flyby.
And now it's literally flyby. And we're actually going to go test this next week. We're going to go to Tom Sawyer Park. We're not going to do it for people, don't worry. But we have a bunch of Raspberries Pi and little embedded devices as well that connect to them. And we're going to sniff essentially for the password hashes and see, can we create like a heat map of crappy passwords and gain an understanding. But that's the white hat version of this.
Right.
What if you're not? Right? And so you can use data scraping and even if you don't know what you're looking at, you can use big data analytics and artificial intelligence to just say, can you make heads or tails out of the signal space? Can you use emissions in various frequency bands to maybe see through walls? I mean, I'm being a little bit hyperbolic here, but you can use AI analytics to give you a lot more information than you normally give. And now you have a platform that can be piloted anywhere. And I don't say that to scare anybody. These still have a limited flight time. They're not, that may be a thing. I don't know.
Right.
But imagine how AI has revolutionized a lot of things that we do today. I mean, we still need human beings. I'm not going to go so far as to say that we can all go and retire now, but it's going to bring more of that in sectors we haven't really thought about. And when you wake, and I fly a lot of these, I'm used to the sound they make. I know what it's doing. It's a very different experience to hear when someone else's is going up to you, and it feels intrusive. So I get how other people feel. So when I fly, I pop way up. I don't want to. I don't want to intrude on people's properties and stuff like that.
Right.
Now you're bringing. Think about the concept of an edge network, right? Where edge computing, where you have a low power device like this. It's not a supercomputer, but you can feed data in real time to something that's got a hell of a lot more processing power. Now you have extended the reach of some of these analytics that might be using AI to wherever you want.
Yeah. Well, I realize I've been incredibly selfish in asking all the questions and not having anyone else.
Oh, yeah.
Our time is tight, but do we have questions here? Or anyone on the chats?
Adrian, have you had any drone crimes committed yet that you've seen? It really does seem like a tremendous opportunity.
Have I seen any drone crimes?
An opportunity to do crimes? Okay.
Okay, so I'll give you three things. On multiple levels. So one is there were cases where drones were shot at, and that is illegal. That is a drone crime.
Even if it's over my backyard.
Even if it's over your backyard because you are shooting into airspace, right? You're shooting at an aircraft.
What is NERF?
What
is NERF allowed?
Nerf allowed? I don't know, because you might be disabling an aircraft, but I don't know.
What's the violation for the person flying the drone in terms of privacy?
Yes, they get hit too, but the person that shoots them also gets hit. So that's drone crime in both cases, right? Then there have been several cases where people were eavesdropping with these things, and it's very easy to find out who did it. There's a reason why FAA is requiring serial numbers to be registered on all these things, because if they catch them, they want to be able to tie it to somebody.
Does the control signal, do they have any identifying?
No, but it's pretty easy to trace if you have the right equipment.
MAC address.
But they're encrypted, so yeah. So that's another is, obviously peeping toms and people like that. It's pretty rare. It's still pretty rare. It's hard to.
You wait.
I was going to leave his windows, his blinds open.
No, let's close those curtains.
I used a drone at my wedding. Actually, I had it fly an autopilot routine, and that was it was a really pretty area. Yeah, of course I did. All right, third case. I've seen people attaching like flamethrowers to these things and fireworks and guns. And don't do that. Don't put a gun on your drone. I mean, you're not going to hit what you're aiming at anyway. But there's some amazing work by I forget what team it was, where one of these aircraft can like duck through trees like faster than anybody could imagine possible with some basic lidars on it. It's wild stuff. And then
what about a spike or a knife? I mean, the creativity of domestic violence.
Well, I mean, you see what's going on in Ukraine. I mean, they're using it for extraordinary stuff, and they're even using fiber optics in cases where they're getting jammed. They just have hundreds of miles of fiber just tangled up, or dozens of miles of fiber, and then they just lay the fiber and off it goes. The third case, I lost my train of thought on it, but if I remember it, I'll give it to you. But drone crimes they're already kind of happening. I think they're pretty restricted in what their cases are, but both to the aircraft and to people. The third case. There allegedly may have been an incident in my lab.
Allegedly.
Where a fail-safe was... I better not talk about this too much.
We are being recorded at the moment.
Where a fail-safe may not have been correctly set. And my students went out, they were in the intramural field at the time, and they went off and they went to fly it, and something went wrong. One of the computers entered a fail-safe state, and my students came back and said, Lauf, it was just gone. It just went up and away, and they never were able to tell it to come back or anything. So I don't know where it's sitting today, but it's pretty close to a crime right there. I'm just grateful nobody's car got hit or person got hit.
Yeah.
It was a stocky little heavy thing too. So
I'll send you the bill.
Right. Yeah.
Nobody's complained so far. I think
nobody's complained so far. Yeah.
They didn't come back.
Yeah.
Well, as usual with these things, we like to end with a student-focused question.
Yeah,
what advice would you give to students or young researchers entering this field of aerial cybersecurity?
So I got into it because as a kid, I always wanted to have a remote control airplane. It was always something that I liked to do, and I always loved computing, and so it seemed like a natural fit for me. So do what you like to do as when you were a kid, bring that passion and energy, because it means you're never going to have a boring day at work, right? The only time I have boring days is sadly because I'm so much focused on the administrative side of things that all my students get to have fun. But I remember in grad school just spending like 6, 8, 10 hours a day just tinkering, messing with profiles and editing configuration files and getting stuff that was dubiously operable to work. So yeah, my biggest thing is if do it because you have a passion for it. And the other thing I will say is that in the cybersecurity, most people know a lot more than they think. It comes down to people v. people, always. The technology is just a medium. If you can identify social behaviors and how they're constructed, then you can also identify technical behaviors and how those are constructed. And yes, there are going to be things that are very difficult to understand, no question, but they can all be broken down into some constituents that we acknowledge and all understand.
As my students are taking their second exam
Yeah.
today, with that thought in mind. Thank you so much for your time today, Adrian. It's been a
Yeah, I hope it was.